but those that are here, welcome. If you could, guys, I really love, as always, to look at your faces. It's really nice to see Robert again after a while. Nice to see Anna. Nice to see Tzvi. Of course, Marie Carla, Darul, David, and maybe I will be able to see somebody else. Christiana, hope you're feeling well, and very happy to have you here. Humira, naturally, very happy. Will I have office hours next week? Which is when? Exactly. Any day. Just plaster me into the wall. I just attach me to the wall and make me part of the university as an exhibit. You can, if you have questions, guys, by all means, ask me, message me. If I'm around, I will do my best to respond. Best, of course, to communicate is, you know, through Zoom, through person to person. So let's recall very briefly some of the things that we have done and some of the things we might have not done. Okay, guys, so we have a circle, and if we measure the arrow of that circle, if we measure it to be a unit, if we say that the radius is a unit, the circumference measures 2 pi such units. In other words, the circumference is roughly 6.28 radius lengths. And that allows us to measure sectors, which are the angles. Remember that degrees are the actual Babylonian slices, whereas the radian measure, the natural measure, is the length of the crust in radius units. Good? Now we defined the basic trig functions. We defined sine and cosine, which you can see here in this picture. This is cosine, this is sine. It's simply just to measure sine of an angle theta. This is some angle theta over here. Just open up rotate the radius counterclockwise until the crust measures theta radius units, and then drop a vertical and create a horizontal, which is in green here. So the vertical length in radius units is sine. The horizontal in radius units is cosine. Good. Now we can see other trig functions in the picture. This is my tangent. Now, why is that the tangent, guys? Remember that tangent is sine over cosine. It's opposite over adjacent. Yes? Opposite over adjacent. Now, when I have to divide by anything, guys, what's the best number to divide by? Do you remember? The best number to divide by is, of course, 1. And if you understand that, you understand why that picture is true, how you can just get there. Do you see it? Look at it. Here I divide this red segment by the green segment. And the green segment, in general, it's cosine. It's in general smaller than 1. So why not extend it? You see that I can extend it to this point. You see, whenever is my cosine, if it's in the first or fourth quadrant, I will extend it here. And I have this dotted line. And if, of course, I am rotating it in this direction, then my extension should be to -1. So I can then extend, if I want to -1, and I have this dotted line. Good? Everybody says it? Now, why I do that is because I just don't want to divide by anything other than by 1 or by -1, as that's very simple. Now look at it. You see this triangle that I drew in the second quadrant? This triangle is it's similar to the triangle that I can create by extending the radius. This is now the triangle. And so the ratio of this blue leg to this ratio is the same as this ratio. Are you with me? So if they are the same ratios, they both represent tangent. The ratio of the blue to dark green is the same ratio as red to bright green. Clear? Do you see that, guys? Which makes, it's very important, which makes this length, it makes it tangent. If this is my, in this case, the theta is up to here. This is my theta, and this is my tangent theta. You see this entire thing in my drawing that I just did here, that's my theta. That will then be the tangent theta in size. It's it's not tangent theta. It's, to be precise, it gives you absolute value because you're dividing by minus here, right? It gives you the absolute value of tangent. Are we clear? Just multiplied by -1 and you see tangent there. So you can very quickly see what happens. I mean, tangent, you can be thinking as traveling along either this line or that line. And say in this case, it will be the negative direction, in this case, positive direction. So if I open up the angle towards pi over 2, you can see that the tangent will just move up and up and up and up to infinity. Good? Now let's try to see if you can understand how can I see in such pictures, where can I see secant, for instance. Let's try to make that picture and you'll help me see secant. So here is a circle and here is some coordinate system. Now I'm going to draw this radius. This is my sine. This is my cosine. Where is my angle theta? My angle theta is, let's draw it in blue. This is my angle theta. I always look at the crust. This is my theta, and this is sine theta, this is cosine theta. Agreed? Now, where in this picture is secant, guys? Can you help me figure out where I can see secant? Or the size of secant, to be precise. So, what is secant? Secant is hypotenuse over adjacent. It's 1 divided by cosine. Do you agree? 1 divided by cosine. Now, what do you want to divide by? That's the question you ask yourself. You want to divide by what number? By 1. And if you want to divide by 1 and you're dividing by cosine, what do you do? Where do you look? You need to deal with equal triangles. Look at it. So extend cosine to this point. You see? You want to extend cosine to be this point. And now you draw yourself this line. And you can extend, look at it. If I extend this triangle up to this edge, I of course have to keep it proportional. So I will extend this up until I touch the dotted line. You see this? Yes? Now, what's the length of that orange line now, please? Type in the comments. And be prepared to explain why that's right, your answer. y2, Francis, I don't see a 2 there. And y cosine plus sine. y2 squared, where do you see 2 here? They're just abstract symbols here. This could be any angle. This could be any length. This could be any length. Of course, all those lengths are smaller than 1, but aside from that, I don't know anything. No, that's not so. Cosine squared plus sine squared is equal to 1. So what's the length of the orange? Come on, guys. You haven't slept well? You had terrible dreams? Yes, you're not seeing it then. So what is the ratio of the black curve to the green curve? Black to green. What's this ratio to green? This to green. It's what? No, of course they're not 1-to-1. How can they be 1-to-1? It's a triangle. Hypotenuse is always longer. We forgot about Pythagorean theorem. Hypotenuse over cosine, which is particularly what? The hypotenuse in this case is normalized to be one length, one unit, because we're always measuring in radius lengths, you understand? We make the hypotenuse 1 so that the measurement on our system is, yeah, so it's secant. So it is 1 over cosine of theta, which is secant theta. Yes. Now the triangle that is extending this black line to the orange line is exactly proportional. Do you agree? So if it's proportional, that means its hypotenuse to the horizontal segment, and the horizontal segment is 1, will stay the same. So that is what? This is also the same as the orange length. I'll just write it as orange over 1. So that means that this here is secant theta. The hypotenuse, the extended orange hypotenuse is secant theta. Do you see that? Type yes if you see that, guys. You see, by the way, as people ask me when is the exam, this is, as I mentioned, prerequisite, guys. This is something you should have been studying, thinking, and learning about way before this class even takes place. And if you have, yes, so you see it, yes? Wonderful. I'm glad you see it. Christiana, you see it? And so what do we have here? So what about maybe one more example? What about telling me what is cotangent? Cotangent. Try to draw it, guys. I see it's a bit uncomfortable for me. I don't see what you're drawing, but try to draw it and see, can you visualize cotangent this way? So here is again that familiar picture. Theta. And now, of course, you see that the red is sine and the green is cosine. Now, what do I do to visualize cotangent here? Remember, the Euro guys, would you just before we ask this question, can you type in the comments cotangent is what? How is cotangent defined? One over tangent, which means in particular in terms of green and red segments. Green and red segments, it's what? Cosine over sine. Thank you, Jahim. So if it's cosine over sine, how do I visualize cotangent? The key is very obvious, right? If I divide by something that's not 1, I prefer to divide by something that's 1. All right, guys, what's going on? Guide me, what do I do? What do we have here? We have sine and cosine. What do we want to change? What do we want to extend or alter? Please tell me. What do I right away look at? Cotangent. Cosine over sine. What's the first thing I pay attention to? All right. You divide by sine. So your first thing you pay attention to is sine. So I would like to extend sine until it's, look at it, this is on the y-axis. I want sine to be equal to 1. Do you see that? Yes, you see this, guys? I extend sine to be 1. Right, where is sine 1? I mean, if I want to, I can draw it right over here. This is my extended sine. And so it's 1. Yes? Now, if I extend sine to 1, I will have to extend, of course, you look at what I do. I extend this triangle. I can think of this as taking this triangle and extending it. Extending it, you see? You see this is red? Now I want this to be red over here. Clear? You understand, guys, what I'm doing? I am just rescaling the triangle. I can drag the triangle keeping proportions, because if you keep proportions, the ratio between opposite and adjacent will be the same ratio. Yes? So I am dividing by sine. I want sine to be of unit length. So here it is now of unit length. This opposite side is of unit length. Now where do I see so the ratio, this over that should be the same as this over that. This is my cotangent of theta. Clear? Good. Well, I hope it's clear. I'm not sure, guys. So clear if you can do it yourself. Otherwise, what's the point? So then what have we established? We have established during the last class that sine is an odd function and cosine is an even function. Giovanni, that's precisely what I do. I'm resizing. When you keep proportions, you're just resizing, and the proportions are kept. Of course, that's a very good way to put it. So here, I just give you geometric reasons to see that that for any angle that you open, sine of negative angle will be negative sine. Do you see why? Guys, look at it. Open theta in one direction, minus theta in the other direction. You see that the sine walls are, one will be against the positive y-axis, one against the negative y-axis. They always are different sides, different, right? Whereas if you look at cosine, it will be symmetric here. It will be the same thing, same segment. So whether I do the opening on the second quadrant or in third quadrant, or in first and fourth, it doesn't matter, right? You would see that you have cosine, it's just this horizontal segment. And then there is this thing that somehow I think a lot of you did not understand, and that is, how do I find the coordinates x, y in terms of sine and cosine? So let's try again. All right, so here is my x-axis, here is my y-axis. Okay, guys? And then please tell me, suppose that that I know that the radius is, that this radius is, let's say, 10 centimeters long. Okay, that means that on the x-axis, things are measured in centimeters. Okay, this point is a particular coordinate x, y. How is x and y related? So x, y, how to describe them? In terms of radius, cosine theta, sine theta. That's the question we consider. Good. So if I have theta, I mean, first of all, what is the angle here, right? So how much do I move to get to the point xy? I have this arc, and this arc, if I move it in this direction, this arc is theta. Yes? This arc is theta. Then what? Where do I see here cosine and sine? X is cosine, y sine, not exactly, because x and y are not measured on the right scale. 10 centimeters is 1 radius. Do you agree? So this is 1 radius. So if you look at it, I can draw the red and the red segment here, and I can draw the green segment over here. So what you can say is that maybe x, I will do this, corresponds to cosine of theta, corresponds, right? It's kind of measured in the same way. Yes, Franz, is x squared plus y squared equal to 100, not to 10. To 10 squared. Good. X corresponds to cosine of theta, and y clearly corresponds to sine theta. Do you understand what I mean by corresponds, right? So y is the vertical length, but I need to measure the vertical length in centimeters. When I say sine theta, cosine theta, I measure it in what units? I measure it in radian units, you see? So sine and cosine represent the value of this altitude in radius lengths. Do you follow? Which will not be the same as the height of, for example, if cosine is equal to 1/2, guys, just a quick comprehension check. Suppose that cosine equals to 1/2. How much does x equal? Cosine equals to 1/2. Do you hear me? How much does x equal? Incorrect. Well, Zvi, you're right. But Miriam and Francis, no. Cosine equals to 1/2. 1/2 what? 1/2 radius. Radius is 10 units, 10 centimeters in length. So x measures 5 centimeters. Do you understand? It's a matter of reporting the units according to the required scale. You convert between centimeters and between radius units. That's as simple as that. So, well, of course it's a ratio, but 1/2 what? When you say cosine is equal to 1/2, it means it equals to 1/2 radius, but the radius is 10. So 1/2 radius. Radius is the same as 10 units, 10 centimeters. Do you understand? So in general, x is this, but what do we know? We know that if I convert x to radian units, I need to divide by 10. So I have that x divided by 10, that equals to cosine theta, exactly equals to. Because take x in centimeters, when you divide by 10, you convert the value of x, you convert that value to radius units. You understand? If x were measured 5, you divide by 10, you get 1/2. So x over 10 is cosine, and y over 10 is sine. That's why with the sine is, you can think of it if you prefer. I mean, it's really the same exact thing. You can think sine is opposite over hypotenuse, right? Sine is opposite over hypotenuse. So the red thing, the length of the red thing divided by the hypotenuse will give you sine. The length of the green thing in the current proportions here, you see, divided by the hypotenuse will give you cosine. Do you understand what I'm saying, guys? So I'm trying to convey something that maybe to some of you seems confusing. I'm not sure why exactly, but I suppose because just you're more familiar with executing a task when you said just take this, divide by that. So this red segment is basically sine is red divided by hypotenuse. What do you do when you divide by the hypotenuse? You rescale to radius units. Is that clear? The reason sine is opposite over hypotenuse is because sine requires you to rescale and report your findings in radius units. So r is normalized to be 1. Is that clear? What is radius units? It means that 1 unit is your radius. So if you make a big circle or small circle, the unit on the x and y axis is the same size as that segment. The units are this size. If I make a radius this way, I change my units and they're now this size. That's what I mean radius units. The radius is a unit. Good? But if I fix centimeters and I change the radius, then of course centimeters are staying centimeters. So they no longer report unit measure of the radius. All right. In general, this is the situation, guys. What is cosine? It's x divided by the hypotenuse, right? Adjacent over hypotenuse, that's how they teach you in school. They say adjacent over hypotenuse. Good. Cosine is adjacent over hypotenuse. I said a little bit more, which might actually create confusion in your mind. Do you understand? Just please report. I just want to see if you understood this explanation, or did it make it more confusing to you somehow? Do you understand that why cosine is defined as adjacent over hypotenuse? Please say yes, or please say no, or you can say confused more. I want to see what's going on there. Okay. All right, not everybody is saying anything. Okay. Good. I hope it's an explanation that you follow, guys. All you're doing is just rescaling, changing the units by which you report. It's very simple. So, yes, our conversion it's going to be important in a moment. So you understand that x is r cosine of theta, where r is the length of the radius in the local system. If I measure in centimeters and my radius is 10 centimeters, then x is going to be 10 centimeters multiplied by cosine. Y is going to be 10 centimeters multiplied by sine. Because by multiplying by 10, I rescale from radius units to the local, let's say, centimeter units. Understand? So, by Pythagoras theorem, we know that cosine squared plus sine squared is 1. We know that because we proved that, guys. You should know the proof. Square the horizontal, square the vertical. You add them up, you get the square of the hypotenuse, which if you report it in units of radius, it will be this formula. If you divide everything by cosine squared, you get 1 plus sine squared over cosine squared, 1 over cosine squared. So what do we get? We get 1 plus tangent squared equals to secant squared. If I do the same but divide by sine squared, I get the formula cotangent squared theta plus 1 equals to cosecant squared. Make sure you understand it, guys. Those formulas become important. Now, in calculus, you're typically asked to compute values for pi over 4, pi over 3, obviously pi over 2, the nodes of the circle, you know, the quartiles of the circle. It's very easy to calculate all the trig functions. You see why, of course, right? Because I know, let's say, if I'm at 0, I know the values of cosine and sine. If I am at pi over 2, I know values of cosine and sine easily. And if I know those values, I know everything else. Cosine and sine will allow me to figure out tangent, cotangent, everything. Good? And so the other values you need to know, it's values that are pi over 4. So you can have pi over 4 in first quadrant, or a version of pi over 4 in second quadrant, or third quadrant and fourth quadrant. It's very easy as soon as you know proportions. Okay? So how do I figure out the values for pi over 4? Take a square with sides 1 and 1, cut it in half. The angle is cut to be pi over 4. And by Pythagoras theorem, the hypotenuse is square root of 2. Good? Hypotenuse is square root of 2, which means that my cosine of pi over 4 is 1 over square root of 2, adjacent over hypotenuse. Again, why do I do that? Because cosine always reports the measurement where I normalize the radius to be 1. Normalize means that I change my units. I think that I'm not happy with the current units. The units I should have are where the radius is of length 1. That's a radian measure. So 1 over root 2, which you can also write as root 2 over 2 by multiplying top and bottom by root 2. Good? Similarly, sine of pi over 4 is also root 2 over 2. Same proportion. Agreed? Now quickly calculate and tell me what are the remaining values at pi over 4 of tangent. So tell me what is tangent of pi over 4 very quickly. Once you have this drawing, it's very quick. What's tangent of pi over 4, please? Okay, Wonderful. Tangent of pi over 4 is 1. Cotangent of pi over 4, also 1, correct? Cotangent and tangent just opposite over adjacent over adjacent over opposite. What is secant of pi over 4, please? And type, so that we're not confused, type secant pi over 4 equal to, please. Thank you, Humira. Thank you, Giovanni. Thank you. Good. And you understand how to get the remaining functions at pi over 4, correct, guys? Is it easy? I hope it is, right? People memorize or have the unit circle, but it's not necessary. You just right away can come up with this triangle. Just take a square, cut it in half, and you see everything. What's there to remember? Equally, you remember Pythagoras theorem. We gave a very easy proof. You can easily construct it. Okay, so now help me do the same thing, guys, but I want you to tell me, let's say, what is sine of 3 pi over 4? 3 pi over 4. Not pi over 4, but 3 pi over 4. What is sine of 3 pi over 4? What is cosine of 3 pi over 4, etc.? Miriam, what is 135? I didn't ask to convert to degrees. I said calculate sine of 3 pi over 4, please. Thank you, David. So quickly calculate sine and calculate cosine just to see that you are picturing it. Thank you, David. Correct. Francis, plugging it in a calculator, no. Give me the exact value. That's not 0.707. Thank you, Christiana. Wonderful. Not all of you right away gave me the answer, guys. Why? I only hope it's because it's too easy. You see this? Here is a circle. Now, where do I find 3 pi over 4? How do I easily figure out what's 3 pi over 4? So pi over 4 once, pi over 2, pi over 4 twice, pi over 4 3 times, pi over 4 4 times will be pi. Do you agree? Pi over 4 4 times is pi. So it's pi over 4 4 times and then go back 1. Pi over 4. So it's pretty much like this. Here is pi over 4 once, pi over 4 twice, pi over 4 3 times. You are in the second quadrant, isn't it obvious? If you're in the second quadrant, what do you see? You see that this is positive. So this is positive and the same length as this. And this part is negative and the same length as this. So it's exactly the same angle pi over 4, but with one of the sides of the triangle being negative. You understand? If I do the same thing for 5 pi over 4, 5 pi over 4 means I move to the third quadrant. You see, because it's 1 more pi over 4 than 4 pi over 4. Yes? 7 pi over 4 is slightly under 8 pi over 4. So that moves you to the fourth quadrant. And all I have to do is understand it's the angle pi over 4 or 45 degrees in the appropriate quadrant. And if I can visualize in what quadrant, I can see which part is positive, which part is negative. Is the x positive or negative? Is the y positive or negative? Good? Now, there are mnemonics, and I've heard of some like Sokatoha or some nonsense like this. I despise that. If you understand what's going on, then you don't remember, right? The amount you remember is minimal. And it's not again about, I mean, you can have machines and calculators that will give you that report. You can type something and it gives you that report. But you can also drive anywhere or be moving in a wheelchair and not walk, right? Then you will become cripples. And you can also become mental cripples if you're not using your brain to think. It's not really that we're trying to figure out what is root of 5. We can check that very easily in the internet, you see? What I'm hoping you are trying to do is to be better thinkers. Sharper thinkers. And mathematics helps with that. You want to see a very simple example? I mean, it's very famous. I wonder if you know about it. There was during World War II this problem with the aircraft, right? So you had those, I'm just going to draw some aircraft. Here is some aircraft, and they asked a statistician to analyze where to place on that bomber more armor. Do you understand? Where do you place more armor on the bomber? So let's just for simplicity divide it into 3 segments. And then basically what they do is they observe the airplane that landed. And let's say they see where the airplane had bullet holes. Okay. All right, they observe where the airplane was riddled with bullets. And the question was, where do you add the armor? So for simplicity, guys, here is sector 1, here is sector 2, here is sector 3. Where do you add the armor? Okay, let's see. Marie Carla says sector 2. And what did Svi, you said sector 1. You see, guys, this is where you have more bullet holes. So David says sector 3. Of course, there are 3 choices, guys. What's the reason? If you say which sector, what's your reason for adding the armor there? So less damage in sector 2. Okay, so some of you might have heard it, or maybe you figured it on your own. And if you did, that's very good. The answer is obviously add it to sector 2, because that means that damage to sector 2 is probably vital, right? If you see an airplane that lands and there's a lot of damage in sector 1, it's the least important. The airplane will fly. But sector 2, damage it enough and the airplane crashes. Okay, that's a very, very trivial example of of what you try to learn to think. Some thoughts are to others paradoxical. Yes, and they become not paradoxical when you think more clearly. Well, let's go back to the trigonometry. So now our task is to figure out the remaining angles. If you did anything in high school with mathematics, you remember they always asked you sine of pi over 4, pi over 2, pi over 6, and pi over 3. Where were they getting those angles? Pi over 6 is 30 degrees, if you want to remember what it is, guys, and pi over 3 is 60 degrees. But think in radians. So what do we do, guys? So we can take an equilateral triangle. Forgive me for the drawing. It doesn't look fully equilateral, but this is 1, this is 1, and this is 1. Then take this triangle and cut it in half. Yes, you cut it in half. And what becomes of it? This side becomes 1/2. You can see this side becomes 1/2. Do you see that the angles are all pi over 3? If it's equilateral triangle, all the angles, they add up to pi, and they must be of the same size. Do you see that? Equilateral triangle, if you draw it correctly, you can just rotate it into place. Just rotate it and it will be fitting in place all the time. All right? So the angles must be all everywhere the same, and they add up to pi. You all remember how we can figure out the sum of inner angles of triangle or any other shape. We did that, and that was easy. So pi over 3 is that angle. You see how I reason it? This angle is pi over 3. Now what is this angle? It's pi over 3 divided in 2. So I have this triangle. Look at it. Side 1, another side 1/2. This angle pi over 3. This angle is pi over 6. What is the remaining side? When I cut it, it's simply hypotenuse squared minus adjacent squared. Take the square root. So that would be 1 squared minus 1/2 squared square root, which is root 3 over 2. So this length is root 3 over 2. Are you with me, guys? I did not go too fast, right? You understand how I know the angles are pi over 3. You understand how I got the pi over 6. And you understand, guys, where did I learn to do that? I didn't. I just thought about it and I just figured it out. And if you did the same, you would have figured it out also. Right? You think about it and you will, if you do it enough, it becomes obvious. So this is pi over 6. This is pi over 2, pi over 3. Now, what is cosine of pi over 3, please? You can see it from the picture. Cosine of pi over 3, it's just adjacent over hypotenuse. So cosine of pi over 3 is exactly 1/2. Right? Cosine pi over 3 is 1/2. 1/2 what? When I say cosine is equal 1/2, what is that? 1/2 what? Type in the comments, please. It's a quick comprehension check just to see if you understand. Right? I say cosine is equal to 1/2. 1/2 of what? Radius, thank you. 1/2 of the radius. As simple as that, yes? In this case, I was able to scale it, so that's unit. That's radian units. Radian units means that I consider the radius to be 1. So what do we have here? What is cosine of pi over 6, please? Cosine of pi over 6. Root 3 over 2. Thank you. Do you see how I know that? What is cosine of pi over 6? Adjacent is now this side, which is root 3 over 2 divided by hypotenuse. So it's just this side. Cosine of pi over 6 is root 3 over 2. What is sine of pi over 6, please? One half. Thank you. You see it? It's the opposite side over hypotenuse. It's 1/2. You can see it from here, right? Opposite over hypotenuse. Sine of pi over 3, it's opposite over hypotenuse, opposite the angle, which is root 3 over 2. And easily you can figure out everything else, right? You can figure out tangent and cotangent of each of those angles. No trouble, right? So for example, if I wanted to know what's tangent of pi over 3, I would take root 3 over 2, divide by 1/2. It will be simply root 3. Tangent of pi over 3 is root 3. Do you see that? Yes? Good. And so this is exercises where you calculate for all sorts of angles. You need to be comfortable with it. And now we come to a very important part of the lecture. Could you please tell me what is cosine of, let's say, pi over 3 plus pi over 6? Yes? So let's maybe I'll help you, right, to do that together. So what we have here is we have cosine multiplied by pi over 3 plus pi over 6. So I just take and I distribute cosine across. And so I just get cosine of pi over 3 plus cosine of pi over 6. Yes? And then what is cosine of pi over 3? Cosine of pi over 3 is 1/2. And cosine of pi over 6, we saw before, it's root 3 over 2. So the answer is 1 plus root 3 divided by 2. Agreed? So understood, guys, how I did it? Please confirm, and I want to see a lot of confirmations. Okay, you all understood how I did it? 8, 9, I mean, I want to see 28 messages here before I open them. I only see 12. Why not more? 12 is not 28, guys. Last I checked. Even if I permute 2 and 1, right? I still don't get 28. Okay, you understood? Yes, you understood. It's very terrible that you understood, because what I said is absolutely and unequivocally wrong. And you can see immediately that it is wrong, because cosine of an angle cannot exceed 1. But don't you see that this is bigger than 1? Because, no, it's unequivocally wrong, right? And if you don't, I mean, it was maybe fast, who knows, right? I mean, why? Look at it. Even my explanation. Look at the explanation. You move cosine here, you move cosine there, right? And what happens when people don't understand? Well, they begin first placing one mask over their face, and then they place 2, and they would place 7 if they're told to place 7, because they believe, right? That's what happens. Right? They don't think about the justification or the math or anything else, or they think that simple things are simple. Well, they think that difficult things are simple, right? And the simple things are difficult. It's absolutely and terribly wrong, right? Unimaginably, inconceivably wrong, because there is no multiplication. It's just an operation that. But what is cosine, right? It's like if you are eating food, guys, right? When you go home and you eat food, are you multiplying the food? What is it that you're doing? You're not. Let's say when you eat, let's say one roll of ice cream, or whatever you call it, one ice cream cone. Are you what? Are you multiplying it by 7? right? What cosine is doing, how is it processing its input, we haven't described. We don't really understand it too well at the moment, right? What's happening is, let's say if I say Arkady has eaten ice cream, right? It's not Arkady multiplied by ice cream. It's a very complicated digestive process what's happening to the ice cream, good? Which we will try to understand right now for cosine. It's absolutely wrong. So first we begin with cosine of beta minus alpha. We will try to extract a formula of sum and difference of angles. So bear with me, guys. It might be a little bit difficult. I hope not too difficult. Okay. Here is a simple example that the formula will not work as it is. Look at it. Cosine of 0 minus 0, it's cosine of 0, right? It's equal to 1. Obviously, it will not be equal to cosine of 0 minus cosine of 0 because that would be 0. Are you with me? You understood? With very, very quick verification, you see that it's not going to be distributing cosine to the two angles. It cannot be possibly the formula. And what is the situation? So let's try to draw triangle this way. So let's say we open up the line to the angle alpha and we open up a further line to the angle beta. You see in red it's beta, in blue it's alpha. Yes? The coordinate of this point is cosine alpha sine alpha. Do you see why? We spoke about converting xy coordinates to trig functions. In this case, because this is the radius. Radius is of unit length. This point is simply cosine alpha sine alpha. And this point over here is simply cosine beta sine beta. Are we clear? Solve what? I'm sorry, Angelo. When you say it, you see, when I try to derive a formula, it's abstract, so I don't have particular angles available for me, right? I don't have one angle. If you mean the previous problem, if I could combine it, but that's not important. I can solve it either using what I'm developing now or perhaps even directly by adding the angles, right? What's important is what's the formula in terms of cosine of sum of angles, cosine of difference of angles. You see that? So do you all see why this is cosine beta sine beta, this is cosine alpha sine alpha, or any trouble? Please confirm that you see it, guys. I need to, it's vital. Yes. So the angle in green between them is simply, what is that angle? It's just, Francis, what do you not see? It's just back to this situation here. If this point is xy and the radius is r, the coordinates x is going to be r cosine, the coordinate y is r sine. So that's beta minus alpha. Zoom in on what? I'm sorry. You want? I can draw another picture if you prefer, right? If it's easier. I'll draw another picture just in case it somehow makes it easier for you guys. Okay, here is the situation. Okay, so again, unit circle, and here I have the angle alpha. And somewhere else, I have the angle beta. I can, if I keep scale to make it unit circle, I'm just trying to establish I'm trying to establish a formula that relates cosine of beta minus alpha to cosine alpha cosine beta. You understand, right? I'm trying to come up with a formula. This is a bit clever. This is called trigonometry, Francis. Good. Now, what is this angle, guys? This angle between, if this is beta and this is alpha, the angle in green that I drew over here, it's this angle over here, it's beta minus alpha. Do you agree? Because it is the blue minus the red. It's the angle I have there. Good. Now, please let me see if you follow. Please tell me what are the coordinates. What are the coordinates along this point in terms of alpha and beta? What is the coordinate along this point? Yes, I'm asking the coordinates of this point. You see, we rotate, we go here. What is this point? Coordinates. Yes, well, no, Zakarian, not, why do you have alpha? So you rotate fully by beta. So what is this point? This point is cosine beta sine beta. Yes, good. You see that? Not just because I say, guys, not because I pressure you, you see it, correct? I mean, it's just, you see, we have here this segment, that's my sine. And this segment is my cosine. This is cosine theta. This is sine theta. So you see that cosine theta matches the x position and sine theta matches the y position. Yes? And the only time we multiply by cosine and sine by any other values, that's if they are not in the right scale. Because cosine, it's really the x position, but just it measures it in radius units. Sine is really the y position, but measured in radius units. In this case, since the hypotenuse is 1, this line is 1, that means we are using radius units and there is no need to convert. You understand? So you are correct thinking that cosine is x and sine is y, correct up to reporting the right scale. You understand? Why cosine cannot exceed 1? It's because cosine is never longer than the radius. That's really what you say that, right? Clear? Angelo, you understand? Great. And if so, what is this point over here? What's the coordinates of that point? Thank you so much, Humira. This is cosine alpha, sine alpha. And so now I will measure I'll draw it, I think, in this color. This is my C, right? Now we have distance formula. Do you all remember distance formula, guys? What's the length of C? I know that C squared equal to, so C squared is equal to cosine beta minus cosine alpha squared plus sine beta minus sine alpha squared. Do you all understand how I got such a formula? For C, if I have two coordinates, I have, it's really just in case you forget, guys, this is the situation. If you take any line segment, right? What's the distance formula? The distance formula is if you have this coordinate is A, B, and this coordinate is C, D, then you can complete this triangle. You can make it a hypotenuse of a triangle where the length horizontally here is C minus A, and the vertical length of that triangle is D minus B. And so the hypotenuse is simply this hypotenuse satisfies Pythagoras theorem, h squared equal to C minus A squared plus D minus B squared, yes? So that's C minus A squared plus D minus B squared. Understood? Yes? That's just a distance formula that I use if I have those points. So here I have this, this C squared. Now, if I simplify it, look at it, guys. When I simplify C squared, what do I get here? So cosine squared, so it would be, so again, what we obtained is C squared equals to cosine B minus cosine A squared plus sine B minus sine A squared, which is what? So this is cosine squared B minus 2 cosine B cosine A plus cosine squared alpha plus sine squared beta minus 2 sine beta sine alpha plus sine squared alpha. What happens is that we can now simplify something here. We know, for instance, that sine squared alpha plus cosine squared alpha, those things are equal to 1. And we know that that cosine squared beta plus sine squared beta also equal to 1. So the result is simply 1 plus 1, so it's 2 minus 2 parentheses cosine beta cosine alpha plus sine beta sine alpha. Good? You understand this calculation, guys? Yes. Now this is one calculation that we do, and then we have another calculation. Look at it. I can take this triangle and I flip it on the side. Remember this triangle, guys? This triangle with the C. I flip it and I bring it down. I bring this line to lie on the x-axis. That will tip the triangle. Yes? So you understand what I'm going to do, guys? I am going to take this thing and I'm gonna lay it flat on the x-axis. Okay, so what is the coordinate here now? I lay this flat on the x-axis. What is the coordinate of this point, please? In simplest possible terms. 1, 0. Very good. You see it's 1, 0. Now, here is the $1,000,000 question. What's the coordinate here? You understand what I'm doing, guys, right? I am taking this triangle. It's now balanced. It's unstable. So I push it, and the triangle rigidly falls on the x-axis. So what I have is this segment, right? So this segment is staying the same length. This is still C. Do you agree? Because the triangle rigidly was moved. C represents the length of that segment. What's the coordinate of this point? Okay, what's happening there? Okay, 3 people. Yes, Zakaria, very good. And a few others, I think, good. Do you see that the angle that we rotated, this angle is beta minus alpha. This angle now is emanating from the x-axis. You see this? Emanating from the x-axis, so it's this angle. Everyone sees it? So that means that the coordinate in this point now is cosine beta minus alpha, sine beta minus alpha. That's this point. Good? And once you have that point, you now have this calculation that you carry through. Here is the calculation I just did on one of the pages there. You see, I simplified the first calculation to be 2 minus 2 cosine beta cosine alpha plus sine beta sine alpha. And on the other hand, I can use the other formula. The other formula tells me take the point, subtract 1, 0, which is, and then just square it, and that will give you again c squared. Are you clear? This same c squared this c squared was calculated as the distance between those 2 points, but it's also the distance between this point and that point. So what do you get? You get that c squared is cosine beta. So c squared is cosine beta minus alpha minus 1 squared plus sine beta minus alpha minus 0 squared, which is this formula. And then when you simplify, cosine squared beta minus alpha and sine squared beta minus alpha disappear. There is the 1 here. And what you get is 2 minus 2 cosine beta minus alpha. Now look at it very carefully, guys. Do you see that the both formulas give us a c squared? So it means that this full formula is equal to this full formula. And that means in particular that if I look here and I look here, they are the same. They must be the same, you see, because everything else is the same. So this must equal to this. Good? And we got our sum of two angles formula. This is the formula, guys. Look at it. So cosine of beta minus alpha is, what you do is to calculate cosine of beta minus alpha, you calculate cosine of this angle times cosine of the second angle plus sine of this angle, sine of the other angle. It's the minus is a plus here. And this is what the formula implies. Right, so for instance, if I, I'll get there in a moment, right? Let's see. So for instance, I want to understand what is cosine of pi over 2 minus theta for any theta. That would be cosine of pi over 2 times cosine theta plus sine of pi over 2 times sine theta. And look what I have here. I get that it's equal to sine because cosine of pi over 2 is 0. So cosine of pi over 2 minus theta I see equals to sine of theta. Are you with me? And what it means, guys, what does it mean? It means that cosine of pi over 2 minus any angle equals to sine of that angle. Now, here's a comprehension check. Can you tell me, please, what is sine, and use that reason before? So use this reasoning. So we just verified that cosine of beta minus alpha, it's cosine beta cosine alpha plus sine beta sine alpha. And now we have, and now we verified that cosine of pi over 2 minus an angle theta using this property, right? It simply is sine theta. I want you to use this information here to verify that implies 2. Well, that allows us to solve immediately what is sine of pi over 2 minus theta. Explain why and calculate. So tell me what is sine of pi over 2 minus theta and be prepared to explain how do you know. You see, we proved this identity. That identity immediately implies this identity. And I'm claiming that this identity 1 immediately implies identity number 2. Yes. Okay. So it's cosine theta. Thank you, Christiana. You did it exactly as I was asking, right? So this is the idea, guys. How do I know this? You see, this is what I mean. What is logical reasoning here? So what is that statement saying? Don't focus on the theta. This means cosine of pi over 2 minus any angle is sine of that angle. So I can take that angle to be this thing. Okay, sine of that angle, according to the top formula, is equal to cosine of pi over 2 minus the angle. You see the logic, guys? There is no, theta is just a symbol. This is just saying cosine of pi over 2 minus any angle is equal to sine of that any angle. And sine of an angle is cosine of pi over 2 minus the angle then, right? And then very easily, look what happens. Pi over 2 minus pi over 2 minus theta. This is simply cosine of theta. So we have this identity. Cosine of pi over 2 minus theta is sine theta. Sine of pi over 2 minus theta is cosine theta. That means those functions, which is of course obvious geometrically, they are very similar. Cosine and sine geometrically is actually the same function, same curve. Another thing, guys, in case it's useful, in case you see, this is showing you geometrically why you might expect this property. Look at it. Here is 1, here is theta. So sine, this is sine theta, this is cosine theta. But similarly, I have this remaining angle. This angle is pi over 2 minus theta. Now, sine of pi over 2 minus theta is this length. It's opposite to this angle. And this length is the same as cosine theta. And cosine of pi over 2 minus theta, it's this thing, this side, which is the same as sine theta. So geometrically, drawing that picture makes it rather obvious that those will be the results. Good? We will use them to figure out the remaining formulas. So now I want to understand, first of all, what is cosine of beta plus alpha. So cosine of beta plus alpha is cosine of beta minus alpha. You see, I want to be a negative in here, which is cosine of beta, cosine of minus alpha, plus sine beta, sine minus alpha. Now, cosine of minus alpha is cosine alpha because cosine is even. And sine minus alpha is minus sine alpha because sine is odd. And I get this formula. Cosine of beta plus alpha is cosine beta, cosine alpha minus sine beta, sine alpha. Now, finally, I want to know what is sine of beta plus alpha. You see, as soon as I have, this was the difficulty, right? As soon as I have this formula, I rather fast can establish the remaining formulas. So for instance, what is sine of beta plus alpha? I can convert it to cosine. This is cosine of pi over 2 minus beta plus alpha. You agree? And this I can rearrange to be cosine of pi over 2 minus beta minus alpha. And now it's the sum, it's the difference of two angles. So that becomes cosine of the first times cosine alpha plus sine of this times sine alpha. And then I can convert cosine of pi over 2 minus beta, it's simply sine beta. And sine of pi over 2 minus beta is cosine beta. Are you with me, guys? I say cosine, sine, alpha, beta. Are you able to follow? I hope I am not losing you. It's technical a little bit, but hopefully you understand. Because I see that more and more of you are disappearing. Why are you disappearing? Like I now see 1, 2, 3, 4, 5 people. What happens to the rest? slowly. Well, so we need to pump more into it, Francis. Yeah, some of it is a bit technical. What can I do? Yes, I have a bad voice. People want me to sing a song. Yes. My favorite is called a song about parrot Yossi. Do you know it by any chance? Maybe it's if you speak Hebrew. You know Shir al Tuki Yossi? No? Never heard. That's too bad. I'll buy me a parrot and name him Yossi, and with him I will speak of things that no one will hear. And then I will tell him, do you know, parrot Yossi, sadness like glass she is, in her bitter wine. And the reason I remember that song is they say, with a voice of a poet whose heart is rage and fire among callous and indifferent hearts. You know what? So that you will, so that you have a short break and breathe a little easier, we will listen to this silly song, right? I always think it's about trigonometry. Okay. Let's pause the video for a moment. And we are back. As I mentioned, when I think I go like, the radius. It took me a while to find the song because I thought they were singing about the radian measure. You understand? That's why I think, oh, the radian, whoa. Right? So I imagine the wheel is rotating and she is singing about how the radius is measuring the circumference of the circle. All right, back to this thing. Come up. Yes, she has a good voice. Why not? Although the song is a bit drawn, but the popular thing is on the radio, I think, right? Everybody knows that part. So here is what we have established, guys. I hope you can focus. I hope you can process. And again, turn on your cameras so that I can look at you guys. I'm losing vision. That's not good. Zayed, where are you? Marie Carla, Francis, you used to turn on the camera some time ago. Darul, great. I think you might appear. Zakaria, you disappeared. Elisha, Tzvi, where have you gone? Humira, would be wonderful to see you if, you know, right? It's Noshin, who else is there, right? Come on, guys. We cannot get to the critical mass where nobody appears. It will be so boring. Yes, of course. I thought about that if I put cameras on as a grade, but then some people might really not be able to turn the camera on. I hate pushing people. I considered, you know, some grade incentive, but it's also very, how do you say, corrupt. So cosine of beta minus alpha, we have a formula for beta plus alpha, beta minus alpha for sine, and you know, we have all those formulas, which of course, guys, you have this break and you want to justify it. You want to be able to, the way you study, you don't open this book. Well, I mean, you know that you're pretty, the first part, most of you do very well. You don't open the book. But the second part, you actually take it and try to see, do you understand it? Is it all sticking in your head? Is it all very simple in your mind? And if so, even if for some reason that is inconceivable to me, you don't care about the subject, it is what will make a big difference between a good grade and a bad grade. Trust me, I know that, right? When I decided I want to study it, I decided I will love everything. I will prove everything like a bureaucrat. I will investigate everything. Every little thing I will turn. No stone will be left where it stood. And that allows you to make calculus seem like a pebble and nothing more. Here is what we immediately get, guys. Cosine of 2 theta, it's cosine of theta plus theta, which is cosine theta times cosine theta minus sine theta, which becomes cosine squared minus sine squared. Good? I'm just right away, I mean, the formulas are flowing out of me like after a binge drinking night, you know, a drink is coming out, right? Just one after another. Look at it. Cosine squared minus sine squared, 1 minus, and look at it. I can convert cosine into 1 minus sine squared, and that gives me this formula, 1 minus 2 sine squared. Or I can take sine squared and I can replace it by 1 minus cosine squared, and it gives me that formula, you see? And I can also obtain the formula of sine of 2 theta, which is 2 times sine theta cosine theta. Now, let's do a practice question, guys, right? Let's see if you are with me. Can you produce a formula for tangent beta minus alpha and for tangent beta plus alpha, or tangent 2 theta? Let's see if you can produce a formula for tangent of a difference of 2 angles. Go ahead, I'll give you 5 minutes. Could you, Christiana, could you come up tangent beta minus, beta minus alpha, essentially what you wrote? What is tangent of beta minus alpha in terms of some trig functions? All right, so what's an obvious first step? It's obvious that we do what? We can think of tangent as sine of beta minus alpha over cosine of beta minus alpha, yes? The very natural thing to do is to bring it back to identities we are aware of. Now, the numerator, oh, great, Christiana. Very nice. So then I look at the numerator and I think, okay, what's the formula? This is going to be sine of beta cosine alpha minus cosine beta sine alpha. That's the numerator. And the denominator is cosine beta cosine alpha plus sine. Sine alpha. Good. Next, what we can do is we can divide numerator and denominator by, say, we're going to make it tangent, so we can take the sine of beta needs to be divided by cosine beta. So in fact, we're going to divide by numerator and denominator by cosine alpha, cosine beta. Okay. You see why, guys, right? So I'm going to divide numerator by cosine alpha, cosine beta, because dividing by cosine makes a tangent. Yes, look at it. I want to convert sines and cosines to tangents. Yes. So when you see sine, you want to divide by cosine, right? Tangent is basically divide by cosine is what I hear. So I look at it, I have cosines here, cosine alpha, cosine beta. So I will divide numerator and denominator by cosine alpha, cosine beta. Because in particular here, if I divide by cosine alpha, cosine beta, it will destroy the cosine alpha and it will convert sine beta to tangent because there will be cosine beta here, right? So dividing this part by cosine alpha, cosine beta makes this tangent beta. Dividing this by cosine alpha, cosine beta will make this minus tangent alpha. Divided by, this is simply 1. And this is tangent alpha, alpha tangent beta. That's the formula for difference of angles and tangent. Clear? You understand, guys? What motivates it? Very simply, I know that if I have sine and cosine, tangent is produced by dividing by cosine. So I divide by all the cosines I possibly can divide by, and I get this formula. All right. So then there is also another thing we need to learn, and hopefully we can then do a few practice questions. So half angle formulas, right? So I can get to half of an angle, or we see cosine of theta, it's the same as 2 theta over 2, which is the same based on this formula. Look at it. Cosine of 2 times an angle, it's in terms of cosine, it's 2 times cosine squared minus 1. So cosine of theta, it's cosine of 2 theta over 2, which is 2 cosine squared theta over 2 minus 1. Which means what? Which means that cosine squared of theta over 2, this part, it's the same as 1 plus cosine of the angle divided by 2. Similarly, I can get a half angle formula for sine. I can say cosine of theta, it's also cosine of 2 theta over 2, which is equal to, I'm using now the second formula, right? This one, the first formula, sorry, this one, right? So I would say 1 minus 2 sine squared theta over 2, Converting it, you get sine squared of theta over 2 is 1 minus cosine of theta over 2. Now let's see how that's useful. Convert, please tell me what is the value of sine of pi over 8. What's sine of pi over 8 equal to? Again, guys, you see how we found the half angle formula? Simply like this. What is, if I want to know what's cosine of theta, I can also write cosine of 2 times theta over 2, which is the same thing as cosine. It's double angle, so it's cosine theta, cosine squared theta over 2 minus sine squared theta over 2. You see this? This formula has both sine squared and cosine squared. Now I can get rid of the other part. Let's say if I just want to keep, look at it here, I only have sine. So I want to keep only sine as my formula. So I can get, I can say that cosine squared, it's what? It's 1 minus sine squared of theta over 2, right? I can replace this part by 1 minus sine squared of theta over 2. So altogether, I have the formula 1 minus 2 sine squared theta over 2. And that brings me back to cosine, which means what? Which means that if I move things around, look at it, just solve this equation. I have that sine squared theta over 2. It's equal to 1 minus cosine of theta divided by 2. That's the formula that I can use. Why can I use it? Because look at it. So I have that sine of pi over 8. It's the same as the square root of sine squared pi over 8. Yes, which is the same thing as the square root of 1 minus cosine of the angle doubled. Cosine of 2 times pi over 8 divided by 2. You agree? You're following me, guys? Are you still able to keep up? That's good. So that's good. Like this, right? So what is that? I know what's cosine of pi over 4. 2 times pi over 8 is pi over 4. Cosine of pi over 4 is root 2 over 2. So what I have is root of 1 minus, so I can do it maybe here. So what I have is root 1 minus root 2 over 2 divided by 2. And I can simplify it, multiply top and bottom by 2. So that's the same thing as root of 2 minus root 2 divided by 2. And I have my formula for sine of pi over 8. Would you help me find the values of sine of pi over 12, cosine of pi over 12, and tangent pi over 12, please? All right. Giovanni, there probably is another root. Just a second. So let's see. So you understand, guys, the idea. The idea is that here's what happens. Sine of pi over 12 is the same as the root of 1 minus cosine of 2 times pi over 12 divided by 2. That follows from this formula here that you can establish. You see? What does it mean if you take the angle? It's divided. See, when you say it's divided by 2, it's no longer divided by 2. It means you're doubling that angle. Take this angle, here it's doubled. Good. And what is that value? This is root. So it's cosine of pi over 6. Cosine of pi over 6 is root 3 over 2. So it's 1 minus root 3 over 2 divided by 2. Agreed? Which is, if I multiply this and that by 2, I can write it. I can write it as 2 minus root 3, close the square root, divided by root of 4, which is by 2. So it's 2 minus root 3 divided by 2. Let's see what was answered. So slightly wrong, I think. So then what is cosine of pi over 12? Cosine of pi over 12 is, it's really root of 1 plus cosine of pi over 6 divided by 2, which will simply be, once you simplify, root 2 plus root 3 divided by 2. Good. Tangent is just take the ratio of those two quantities. The next part, we begin taking the derivatives, but I have a feeling that over this mountain, I'm not going to drag you today. All right, so if you are, guys, if you are tired, you are welcome to say goodbye to me. Take care. We'll end this lesson a little earlier because 3 minutes will not explain much, and I presume you have covered a lot of technical things. I hope what we did today was not in vain, that you understood it. Yes, and you could repeat it on your own.